High above us, an invisible force surrounds our planet. This force field, called the Earth's magnetic field, protects us from harmful radiation from the sun. But there's a strange region where this shield is weaker. It's called the South Atlantic Anomaly, or SAAA for short. The SAA sits over South America and the South Atlantic Ocean like a dent in the Earth's magnetic field. The Earth's magnetic field is like a giant bar magnet. It has a north pole and a south pole. Invisible lines of magnetic force stretch out from these poles, wrapping around the planet. This magnetic field acts as a shield, deflecting most of the sun's harmful radiation. This radiation is made up of tiny particles that travel through space at high speeds. The South Atlantic Anomaly is a region where the magnetic field is weaker than normal. This means that the protective shield is thinner in this area. Think of it like a thin spot in a bicycle tire. The SAA allows more of the sun's radiation to get closer to Earth. The Earth's magnetic field is generated deep inside our planet. The Earth's core is made mostly of iron and nickel. The outer core is liquid metal and is constantly moving. This movement creates electric currents, which in turn generate the magnetic field. This process is called the geodynamo. The SAA is thought to be caused by changes in the flow of molten iron in the Earth's outer core. Imagine a river that becomes wider and shallower in one spot. The flow of water slows down in this area. Similarly, the flow of molten iron may be slowing down in the region of the SAA, weakening the magnetic field. Section 5. Impacts on satellites. Satellites orbiting Earth rely on the magnetic field for protection from the sun's radiation. When satellites pass through the South Atlantic Anomaly, they are exposed to higher levels of radiation. This can cause problems with their electronics and instruments. Imagine a satellite passing through a hailstorm. The hailstones represent the sun's radiation. A weaker magnetic field means less protection, and the satellite is more likely to be damaged. Section 6. Mitigating the risks. Space agencies are well aware of the SAA and its potential impact on satellites. They take precautions to minimize the risks. One common strategy is to temporarily shut down sensitive instruments when satellites pass through the SAA. Think of it like turning off your computer during a power surge. By shutting down non-essential systems, satellite operators can protect their spacecraft from potential damage. Section 7. Modeling the anomaly. Scientists use satellites to monitor the SAA and track its movements. They also create computer models to simulate the Earth's magnetic field and predict how the SAA might change in the future. By studying the SAA, scientists can learn more about the Earth's core and the processes that generate our planet's magnetic field. Imagine trying to understand how a car engine works by listening to the sounds it makes. By studying the SAA, scientists are listening to the sounds of the Earth's dynamo. Section 8. A look back in time. The Earth's magnetic field is not static. It has changed many times throughout our planet's history. In fact, the magnetic poles have flipped many times, with north becoming south and south becoming north. These flips are recorded in rocks that preserve the direction of the magnetic field at the time they formed. Imagine a compass that suddenly points south instead of north. That's what happens during a magnetic pole reversal. Section 9. The future of the SAA. Scientists are not sure what the future holds for the South Atlantic Anomaly. It might continue to grow and weaken, or it might eventually disappear. However, one thing is clear: the SAA is a reminder that our planet is a dynamic and ever-changing place. While the SAA is a fascinating phenomenon, it's important to remember that it's not a sign of an impending magnetic pole reversal. Such events are rare and happen over very long periods. The SAA is simply a reminder of the complex and dynamic nature of our planet's magnetic field.